So, how do you collect telemetry data from the Azure platform? Well, it depends on the data type. One of the things that are automatically collected are activity logs. These give you information about configuration changes, resource health, and so on. We're looking at the app service for our API, and I've clicked the activity log menu item here on the left. Nothing happened in the last 6 hours. That kind of makes sense. I have to sleep from time to time, so I don't record these courses in one go. But let's put the time span to 24 hours, and we should see a few things coming up. Here we go, that's better. It looks like on this app service in the last 24 hours, I started the website, started the web app, deleted a few extensions, updated some configurations, and so on. In other words, this gives me a nice overview of all events that happened related to this app service. We can, by the way, also create alerts for these, as we did in the previous section. Interesting to know is that you can also look at the logs from the level of a resource group or even a subscription. Let me open the resource group for all things travel inspiration. And let's go to the activity log and set the time span to the last 24 hours. And now we get an aggregation of all the Azure platform events that happened to any resource in this resource group. For example, we see here that I created an alert at the end of the last section. So, depending on how you've organized your resources, this can be a very convenient way to get an overview of everything that happened to resources related to one specific application. Alright, that's one type of telemetry data from the Azure platform, but next to logs you've also got platform metrics. What exactly is collected here too depends on the resource type, but the interesting part here is that these two are collected automatically. We can view them by opening the metrics blade at level of a resource. Clicking the metrics menu item opens Metrics Explorer. Here you can select a specific metric you want to view, say CPU time, select an aggregation, choose the type of chart, and even combine this with other metrics. From here too, you can create new alert rules if you wish. So this is interesting, but not all metric combinations are equally useful. Yet, if you combine them well, they can quickly help you identify issues. For example, if you combine CPU time with the memory working set, in other words, the amount of memory your application uses, and if you notice that both are pretty high, you're dealing with a resource-intensive operation. And that may be an indicator that you need to consider scaling your app. Another example is combining the number of HTTP requests with the response time. If you then see that when the number of requests increases, the average response time for one request also increases, you've got a good indication that your application is struggling to handle the increased load. So, time to look into code optimization or scaling here too. Lastly, if you see a lot of level 400 errors relative to the total number of requests, there may be issues with requests coming in from a client. Maybe your clients don't know how to correctly form a request or how to correctly authenticate. That may lead to having a look at the client app, or if client apps are not under your control, better documentation for those that need to integrate with your application service. Many more useful combinations are possible, but I hope that these few examples already show you how useful Metrics Explorer can be. The last data type is the resource log data type. I can't show you these yet. These provide insights into operations that were performed within an Azure resource and also vary per resource type, but they are not collected by default. To collect these, we need to create a diagnostic setting that will send these logs to a destination of our choice so we can inspect them. A typical thing to do is send them to your log analytics workspace so you can query them, set up alerts for them and so on, just like we previously did. Let's learn how to do that. In this clip, I'm going to create a diagnostic setting to send Azure resource log data to our log analytics workspace. But first things first, what is a diagnostic setting? Well, it's a feature that allows you to configure how metrics and logs from Azure resources are routed to different destinations. you can find and configure them in the diagnostic settings blade of your Azure resource. As you can read here, one of the things we can select in this case are the app service platform logs. But you can select other things as well, as you can see. These are different depending on the resource type, so let's open the storage account to compare. Let's navigate to the diagnostic settings blade. We're looking at the diagnostic settings blade of our storage account now. And as you can see, this already looks a bit different. Let's select Blob here. And down here you can see the data that can be collected with the diagnostic setting. This is definitely different from what we could collect from our app service. If we click Add Diagnostic Setting, we can effectively create a new one. We give it a name, we select what we want to collect, and then we select where to send it to, for example to a Log Analytics workspace. I already did that before this demo to make sure that we have something we can look at and inspect. That's this Send All Logs to Log Analytics Diagnostic setting. I simply selected everything and sent it to our Log Analytics workspace. In case you're wondering, this too can be created and managed via the CLI with the AZ Monitor Diagnostic Settings command and subcommands. Alright, seeing we are sending all logs to our Log Analytics workspace, let's navigate to that Log Analytics workspace. We can easily find it via all resources. Here's the Log Analytics workspace, let's open it. Now, how do we query this data? Well, let's open the logs here. This looks familiar, I think. We can find a few log management related tables on the left already that give us some inspiration of what to query. But what exactly is it that we need to query to get a hold of the logs we are sending from Blob Storage to this Log Analytics workspace? Well, how to exactly query it depends on the type of resource. Some resources send these logs to the Azure Diagnostics table. Well, let me just send a query to that. And we don't see anything. And that actually makes sense because a storage account Blob service does not send its logs to the Azure Diagnostics table. An Azure SQL database does, and so do many others. You can find a list of those that do via the link on screen. So, all the Azure services you see in the list here send their logs to the Azure Diagnostics table. But I'm not going to demo that because slowly but surely the idea is that every Azure resource will move to a resource-specific table as destination for a specific type of telemetry data. A Blob storage account service is one of those that has already moved to the new way of handling things. You can query those by querying the resource type table. In our example, that would be the storage Blob logs table. So let me just query that one. And here we go. Here are the logs we sent to this Log Analytics workspace from Blob Storage. In case of a resource type that has different categories, like an app service, you get different tables, like app service, app logs, audit logs, authentication logs, console logs, and so on. Likewise, tables exist for other services and categories. Simply start typing the name of the service you want the logs to be collected from to figure out the table that you need. By the way, if you don't immediately see these logs showing up, it can take a few minutes or sometimes even 10 to 15 minutes. So don't worry, just be a bit patient. And with that, you know how to use a diagnostic setting and where to find the logs. These can be used all over the Azure platform to collect things and send it to other things. Think of sending the activity logs or platform metrics to an Azure Storage table store for inspection by your custom apps, sending the platform metrics to an event hub for processing, and so on. The way to do that is likewise to what we just did. And with that, it's time for the section summary. In this section, we covered Azure Monitor. Azure Monitor is a comprehensive solution for monitoring resources and apps, including performance, availability, and overall health. It can monitor a variety of resources, including applications, operating systems, databases, virtual machines, and security events, whether they are on Azure on-premises or with other cloud providers. Different types of data sources can be used as input. One of those sources is applications and workloads. So this includes data from apps and related workloads like SQL Server. Then we have infrastructure sources. This means data from operating system event logs and container services like Kubernetes. Then we have the Azure platform itself as a source. This includes data from Azure resources, subscriptions and tenants. And lastly, there's custom sources. Data can be collected via the Azure Monitor REST API and Data Collection API. From those different sources, different telemetry data types are collected. Metrics is an example. These are numeric values describing aspects of a system at a specific point in time. For example, memory usage. Logs are another one. These are recorded events from apps or systems. And we also have distributed tracing. This follows requests as they travel through different services and components. Changes can be monitored as well. These record changes in Azure resources and it's currently in preview. All of this results in the collection and aggregation of telemetry data from various sources into a common data platform. This data can be analyzed, visualized and correlated using tools like Power BI, dashboards, App Insights and Metric Explorer. Important for us as an Azure developer was the Azure platform telemetry data, the data coming from our Azure resources. First of all, there's activity logs here. These are automatically collected logs providing information on config changes and resource health. Then there's the platform metrics themselves. These are automatically collected metrics specific to resource types. And lastly, we had the resource logs, which provide insights into operations performed within Azure resources. But they are not automatically collected. They require diagnostic settings to be configured. So that's what we looked into next. Diagnostic settings allow you to configure how metrics and logs from Azure resources are routed to different destinations. So, if you need resource logs to end up in destinations like log analytics workspaces or storage accounts, that's what you can enable with a diagnostic setting. We configured one, and that was the end of this section and the end of this course. This isn't everything Azure can do, but I hope that you now have a good idea on how to get started with it, because that's what the aim of this course was. Look out for the Deep Dive Azure for Developers course for more. I hope you learned something new, and I hope this course was worth your time. I definitely enjoyed making it, and I hope to see you again in another course. If you want to stay up to date on upcoming courses, feel free to follow me on X. My nickname over there is @KevinDocs. One more thing before I go, you're ready to be awesome.